Good morning, good morning, good morning, good morning. I hope I'm clearly visible and audible to everybody. Good morning, good morning. Yes, yes. So, just good morning, everybody. So, 17th of May is just nearing us, is approaching us like really quickly. I can see all those comments. That mock test is difficult. This mock test is difficult. Beta, Silver Boy, Sudha. Then we have Karthik. So, beta, just let me tell you one thing, and a very important thing. You know what? You know actually what? Advance is a paper which is supposed to be offering a common platform to all the students across country. And across country, it doesn't matter that even if you have read some Russian authors or not, because in my time, I'm talking of back 2006 when I've taken my drop, because I also belong to a very small district, Satna in Madhya Pradesh. We didn't even have a CBSE school at that point of time. So we were just MP board students. And you know what? MP board, the board examination papers have only derivations. We even writing a frictional force formula mu into n, a body sitting on a plane mass, mu mg. That was a trick for us because we just learn derivations. And still, after taking that drop, what I mean, yes, during that time also the Francis Carey, these books were recommended to us because yes, the resources were limited. But actually, what JE check out of you is not you buying those $1,000 of books and learning them. No, learning NCRT and NCRT in such a way that you know that what is written in it, not exactly higher, so you will be going and learning those higher engineering, but whatever resource you have, that is NCRT, and stick to NCRT. Yes, for making a good question, like 20% of your JEE advanced paper is good, but that paper, 80% of the paper can be solved with NCRT logics, and yes, with your proper aptitude of mathematical reasoning, that you should be very much vigilant with solving of the into divide that you do. Please make sure that you are focusing more on that area. And today, with the chemistry class that I have for you, Pranav, Silverboy, Falgun, Handa, and everybody, beta, everybody. Okay, good morning, Neha, everybody. Now, the point that I'm making with that, I'll be keeping this lecture very precise, and I have been reading comments of the students, sir, give some IOC inorganic chemistry logics also. So, my initial number of questions will be just involved with the dangerous P block and block chemistry logic, sir. Why? Because JEE means do not ask so those things, so you leave that. I mean, the NCRT even have deleted those chapters, but yes, they are valid for JEE Advanced. So let us revise inorganic by practicing some good level of questions. Why? When I'm saying good level of questions, that means you have to be more and more vigilant with the reading part of yours, because obviously I'll be throwing you with multiple questions. So no offense, but this isn't back advanced paper. हाँ बेटा, so Silva bhai, none taken beta. Why would I take any offense? Because every year the question paper and the nature is evolving, and because a perfect engineer is a person who is ready to evolve. The jugadu word is a desi word for an engineer. So offense none taken, because every year it is challenging your mental ability. But my dear friends, please make sure that you are sticking to your NCRT basics. And yes, after doing that 60-65%, maybe 70% of the advanced paper, then sky is your limit. Go and attempt those extra questions and make that AIR 1 possible for you. Even I'll be the first person who will be celebrating your success. But yes, you can only gain AIR 1 once you are under AIR 1000. So first reach under AIR 1000 by attempting those easy and moderate questions, and then sky was limit, my friend. And we as a teacher will be more than happy to celebrate your success, है ना? But with that intention, beta, let us attempt today's chemistry class. I'll be bringing you mixed packet of inorganic also, some good level questions of organic also, and we'll be concluding the session with physical chemistry, some equilibrium basics. So I hope everybody is ready with their pen and copy. I hope everybody is ready with their pen and copy. Guys, shall we start? Chalo. Before starting, let me just tell you about the Spylens application, this beautiful application which you can store, which you can install from Play Store or Chrome Store. Sir, what it is going to, first of all, it is free. Second of all, once you install it, whenever you browse any video in YouTube, the blue icon will be coming along with it. It will help you to participate in polls also. It will help you to participate in giving the summary of the video also. It will help you to give the memory map, the short tricks, whatever the video has given. Not even PW videos, any educational video that you are watching in YouTube, it will be helping you to summarize that video. And above that, it, for example, you in my class I'm discussing, let's say 20 questions, 25 questions of inorganic chemistry, but you want more questions of P block chemistry. Then you can even ask, go in the drop down section, and in the filter you can ask for more relevant PYQ of JEE mains, or more questions. So there are many resources also which you can avail using this Spylens app. So I hope it is already downloaded in your system, and with that intention, let us start today's job. This is a integer type question. I want you to please read the question properly. So it's an integer type question. I'm giving you 1 minute to participate in it, and your time starts now. Chalo. By the time, let me read some of the comments if any student is facing some difficulty. So please try and attempt, beta. Quick. Beta, yoga duration of the class will be somewhere around maybe 2 hours. We'll be try to keep it very precise. Chalo, very good. Perfect. The reactions that produce, total number of reactions are perfect, silver boy. Now, a very basic, a very traditional question for learning. Perfect, Sarvesh. Perfect, Revant. Good one, beta. Now, sir, we know that copper is a metal which is below hydrogen in the reactivity series. So copper with concentrated sulfuric acid will definitely get oxidized in +2 oxidation state, forming copper sulfate. And yes, but here there will be production of sulfur dioxide also, and water also. So definitely this is an option. Sir, zinc is a more reactive metal than hydrogen. So because it is more reactive, so it will just give that reaction which you have studied in class 10, which is metal plus acid forms salt plus hydrogen gas. So here no SO2 is produced, hence it is not an option. Now sir, any non-metal with with sulfuric acid, which is quite a strong oxidizing agent, also will obviously bring the metal, the element, not the metal, the element into its most stable oxidation state, which is definitely +4. Yes, obviously water will also be released. Sir, the ferrous sulfide, sir, sulfur here also is in -2 oxidation state, and sulfur will obviously undergo oxidation, and again here also you'll be getting this SO2 or SO2 gas. But yes, this iron will be oxidized in form of its higher oxide, which is Fe2O3. So iron over here is in +3 oxidation state. So this is also giving you sulfur dioxide, so an option. Now, ammonium bisulfite, sir, this is ammonium bisulfite. That means first you will be getting ammonium sulfate as a salt. Yes, it can further decompose and forms ammonia. But yes, sir, here also you will be getting SO2, because this sulfur and this sulfur will definitely create that sulfur which will be in its most stable oxidation state, which is rather generally +2 state. Now, obviously the last one, sir, here with PCl5 I'll be getting the oxide which is phosphorus oxychloride. And yes, apart from that, the phosphorus oxychloride, apart from that, what sulfur form you will be getting? Sulfuryl chloride. So what is that sulfuryl chloride? It is SO2Cl2. So instead of sulfur dioxide you will be getting SO2Cl2. That means this is not an option for you. So how many? Okay, this third one also you are getting SO2. So 1, 2, 3, 4. So out of these, 4 are giving you SO2. A very religious question, a very traditional question to learn in organic as well, and obviously an NCERT fact as well. I hope I hope I hope everybody is clear with this. Silver Boy is asking, sir, could you explain why reaction 6 does not? Beta, reactions here, what is the oxidation state of sulfur? If you just check in reaction 6, can you please tell me what is the oxidation state of sulfur? What is the oxidation state of phosphorus? Sir, phosphorus is in PCl5 state. Once it reacts with H2SO4, then beta, what oxidation state sulfur is present in H2SO4? Sir, it is +6 oxidation state. Everybody is clear with it. What else, sir? Here phosphorus is in +5 oxidation state. So beta, once you get oxide, once you get POCl3 as an oxide of phosphorus, here oxidation state of phosphorus is still not changing. And why this H2SO4 is treating, sir? Because both of them are their maximum oxidation state. Both sulfur and phosphorus are in their maximum oxidation state, and therefore both will try to have the same tendencies, and therefore the change of oxidation state rather does not happen. Because if you check SOCl2, then in SOCl2, in this SO2Cl2, I guess the product is sulfuryl chloride. This is thionyl chloride. So here in thionyl chloride, oxidation state of sulfur is +4. But if you make its higher oxidation state derivative, sir, here oxidation state is also +6. So no one is ready to have that electronic transaction. So no redox is taking place, beta. And because no redox is taking place, that's why you have to choose such a product where the oxidation state of the central elements are retained. So that is a predictability you can have. But yes, Silver Boy, I would definitely rather suggest these are P block logics. So if you be with your NCERT, rather it will save your time also. And yes, the predictability will also come gradually once you start attempting more and more questions of such type. I hope everybody is clear with me. Chalo. So this brings us to the next question. Let us see what's the next question. Match the column type. So again, beta, because this is a single correct, so let me give you less time for this. 45 seconds. Your time starts now. Shoot everybody. Try and give the best answer. Sir, what time shall we? Beta, approximately 2 hours. Silver Boy, perfect. Silver Boy is satisfied. Beta, oxidation state determination, no, is a very good means to actually have a predictability in a reaction. So just try and answer. And I mean, yes, in a multiple correct questions, like this is a single correct, you can obviously do that oxidation number analysis, which will help you to predict what is formed. Chalo. Perfect. Black Mystery is here. Black Mystery is saying B. Abhiram is saying B. Sunsi is saying C. Mayur is saying C. Chalo beta. Actually, it is also multiple correct question, beta. But the option that is served to us provides us C as the best possible option. So good, 50% of the students are bang on. Let us try and predict through NCRT, because we are not here to learn JDL, rather we are more interested in NCRT facts. So let us explore and try to resolve the question through NCRT. Now, sir, potassium nitrate once react with ferrous sulfate in presence of sulfuric acid. This reminds us of the famous brown ring test. Remember, the nitrate ion in presence of ferrous ion and medium is acidic. So ultimately we are confident enough that we are going to produce the brown ring complex, which is this. Here this NO is also in +1 oxidation state, iron is also in +1 oxidation state, so overall charge will definitely be +2. So this complex is your brown ring complex. And how it has been formed? Sir, it needs a ligand, which is NO. That means if it will initially definitely produce NO. But yes, sir, after the reaction, because you have acid and neutralization, sort is also taking place, so I'll be also getting water. So that means A will produce Q and R. So A can produce Q, A can produce R, A can produce R, but yes, A cannot produce S. So one, option D is eliminated. You may get a question where you have multiple match, but here you can also have, I mean, this is a data sufficiency question also for you. So inorganic logic and elimination of the option will also be doing simultaneously. Now, sir, zinc we know is a reactive metal, then hydrogen. So sir, again, metal plus acid forms salt plus water. So here obviously what will be produced? Sir, water, that is Q, is definitely going to be produced. But sir, whenever zinc reacts with dilute H2SO4, one more product can be produced. Here metal plus acid will form salt plus hydrogen gas, and because I do not have option of hydrogen gas, so I guess Q is the only possible option here. So that this can be a case, yes, option A is eliminated. Now, so this is HNO3 and this is P2O5. Nitric acid with phosphorus in +5 oxidation state. We definitely know this is a dehydrating agent as well, but rather it removes water from HNO3 and bring HNO3 in what oxidation state? It will bring HNO3 in its maximum oxidation state, because here also nitrogen is in +5 oxidation state. So after dehydration you will be getting the pentoxide of nitrogen. And what about this? This guy will be turned into metaphosphoric acid, a NCRT basic, beta. An NCRT basic, I hope everybody remember that. Sir, but here option is not having this metaphosphoric acid. We just have N2O5. That means this is P. That means C is P. So C is P, C is S. So this is also cancelled. So we have landed up with an answer which is definitely C. But let us explore the last option as well. Sir, this is ammonia, oxidation of ammonia, beautifully produced nitric acid, which is with nitric oxide, which is also a starting reaction for production of nitric acid in your industry. So again, an NCRT fact. So here NO will definitely be produced, and yes, after apart from NO, you'll be also having water. So this can go with R also, and this can go with Q also. So I guess here Q is an option, but yes, we can have R also over here. So option C is your best answer as per NCRT basics, also as per some common sense also. So once you are religious, once you are disciplined with NCRT na beta, your predictability also increases gradually. है ना? Chalo. So let us go to the next question. I guess this question is also a single correct one. So let me again give you 45 seconds to solve this. Try and attempt, beta, by the time I read some comments. Chalo. Silver Boy is asking, sir, in reaction D, how does choice of platinum rhodium catalyst for NO formation while kinetically suppress the formation of C, beta, C. Beta, whenever, Silver Boy, whenever you have two different type of products now, it depends upon the temperature at which they are getting formed. Chemical kinetics tells us that if a reactant is sufficient enough to form a stable intermediate, then what probable product you can think of? You can think of that probable product which has kinetic stability. That through that you can only predict the product as per the intermediate stability. But yes, as the temperature is increased, so sir, reaching the maximum activation energy level is not a condition for us, because any and everybody will reach that activation energy barrier. So after that, what decides the product stability? Which product is more stable to withstand that high temperature? So in that condition, we attain thermodynamically stable product. And hence, yes sir, we how will we know that this particular temperature, like for HBr, even room temperature is considered as a high temperature. Even room temperature is considered as a high temperature. So obviously you should know certain reaction mechanics or facts as per NCERT, and then only you can predict such formation of products, hai na? Yes, a very famous question. I guess most of the students are answering this as well. Answer for the question is, I guess, a beautiful NCERT fact it is. I'm not able to retrieve. Let me retrieve my option. The pi lens, I have just dragged it, I guess, much bottom of the screen, so I cannot bring it up. Chalo, let me explore some different option, whether I can do something of it or not. Now I'll not bring it to so bottom. Chalo beta. So I guess B is your answer, and most very good, very good. 71% of the students have answered Bombay. So good. Now let us explore this very beautiful and interesting fact of NCERT. A very beautiful fact of NCERT. The chromite ore. What are these chromite ores, sir? Fe. FeCr, because Fe is also in +2 oxidation state, and Cr2O4 2 minus. So this is my chromite ore. This chromite ore is treated with sodium carbonate in presence of high temperature and excess of oxygen. So what are the products we obtain initially? Sir, first of all, the precipitate formed is ferric oxide. What is the gas produced, sir? Sir, we definitely know this is the first step to produce K2Cr2O7. So everybody is having that answer with them. So what is actually the gas producer after this? Oxygen is produced. And what is this A? This is A. This A is my starting material, which is Na2Cr O4, the beautiful and famous initial yellow colored compound, which will further be reacting to produce orange color K2Cr2O7. So A is my sodium chromate, and this A is definitely soluble in water. So this is a soluble salt. Now that A, which is sodium chromate, reacts with sulfuric acid, and in acidic medium, what is actually formed, sir? Na2Cr2O7, and this is a orange color solution. And because we know once it is treated with KCl, so displacement reaction will take place and you get orange crystals of K2Cr2O7. This is a precipitate, while this sodium carbon, this sodium dichromate, this is Na2Cr2O7, sodium dichromate is more soluble, and potassium dichromate is less soluble. That's why it is precipitated, and the last reaction is a precipitation reaction, which brings the reaction in forward direction, and the solid crystals, the orange color crystals of K2Cr2O7 is produced. Now, nothing is asked in the question. The only reason I'm explaining you complete thing is because of the fact that you should know these NCERT fact very seriously, beta. Now, acha, okay, sorry. This is obviously beta. Whenever you have carbon CO3 2 minus, then obviously there is a production of CO2. So definitely, thank you. So these are some NCERT facts, beta, which is very, very famous. Even JEE mains love it. Even that three, 4 pages. Even in my previous lecture also I've told you, at least those 3, 4 pages of NCRT, the D block, you should not leave the K2 CR27 and KMNO4 logic. Now, what is my question? My question is where we have compound B. Compound B is what? Sir, compound B is this ferric oxide. So in ferric oxide, what is the oxidation state of the central metal? Iron is in +3 oxidation state. So +3 oxidation state is of ferric iron, and hence the question is not asking you much, but yes, you should know the in-depth of this NCRT beautiful fact, and to make you revise the fact, I have given you this question. But again, beta, a very famous area, a very beautiful area which NCRT loves, again a block chemistry logic. So try and attempt this question, but this is a multiple correct question, so please read it properly. This is a multiple correct question. For this question, I'm giving you 45 seconds. Please make an attempt properly. Could you leave block chemistry and focus? Ha, beta, I'll be coming with organic as well, beta, but I have in my previous advanced sessions also, which I've taken, I've received most of the request from student side that, sir, do something, some one short revision of inorganic chemistry, and I know the pain point of students are from block chemistry area, so I have selected some famous block chemistry questions and assembled them together. So let us discuss few questions from block chemistry, and then we'll be moving to organic. Don't worry. Chalo, perfect. We are having answer. Perfect. Everybody, great. ABC. I guess most of you are answering, so your multiple correct answer is ABC. Let me see. Perfect. Many of you have given the correct answer. Now let us explore the NCRT fact. Sir, ammonium dichromate. Ammonium dichromate on decomposition produces the oxide of chromium in +3 oxidation state. Why chromium in +3 oxidation state is considered as stable species? Because it has got stable T2G half filled configuration. T2G, chromium +3 has a stable T2G3 half filled configuration and Eg0. So that's why chromium +3 is a stable oxide of chromium. What about next, sir? Next, ammonia is decomposed and nitrogen gas is produced. So here this reaction will definitely give you nitrogen gas. Sir, they are azide. Whatever airbags you have in your car, the opening of the airbag is because of what? Is because of this azide. Whenever you bang and smash that kit in your car, wherever it gets smashed, the azide are exposed, and whenever these azide are exposed, the balloon, the airbag gets pumped up, they gets filled with air. But what air? Not oxygen, because else it will be helping the combustion of so the probability of your car after the accident will be enhanced. So we fill not oxygen gas, we fill nitrogen gas. And how we are going to produce that nitrogen gas? All the alkali and alkaline earth metal azides on thermal decomposition, they form nitrogen gas. So this is obviously correct. Now, sodium nitrite with ammonium chloride, yes, initially it will form ammonium nitrite, and soon after decomposition it gives you nitrogen gas and water. So this is obviously NCRT fact, also a beautiful block chemistry logic also. Now, ammonium nitrite, D is no, because yes, Silver Boy is definitely answering, because again, this is the famous reaction by which you create your laughing gas, nitrous oxide, the neutral oxide. Silver Boy is actually correct. So it produces nitrous oxide and water. So that means this is no nitrogen. So only this will be eliminated, which I guess most of you have attempted correctly only. Moving to the next question, beta. Try and attempt this one. Again, a single correct question. So again, I'm giving you 45 seconds for this. Please attempt. Again, 45 seconds for this, beta. Please attempt. Beta, make sure that you're reading the questions very properly. Silver nitrate is reacting with sodium thiosulfate, so that's hypo for you. It is producing a white PPT. That white PPT on thermal decomposition is producing a black PPT. That white PPT is also reacting with excess of sodium thiosulfate and forming a soluble complex. Now you have to tell what is that soluble complex. Perfect, perfect, Ashwin. Perfect. Satish. Acha, Satish is giving answer for previous question. Acha, 12th result aa gaya. Oh my god. Oh my god. Applause for everybody. Just I know you will be more eager to check your results, but invest the next few hours. Maybe we'll be wrapping up around 1 p.m. with me, and then you can obviously explore and go for the options. None of these. Shatru Ghana is saying none of these. Remaining students are answering C. Beta, you can definitely understand because it is just asking you the soluble complex, so it will be definitely a complex of D block. So most of the students are correct. Good, beta. Now let us explore the question. So silver nitrate is a soluble salt. One, it reacts with sodium thiosulfate, again a soluble salt. I initially get white PPT when the amount of sodium thiosulfate is obviously limited. So what PPT is formed due to silver thiosulfates are Ag2S2O3. So it will give you a white PPT. Now this white PPT, once undergoing thermal decomposition, this is my X. Once it is going thermal decomposition, Y is produced, which is a black beta black precipitates are famous sulfide PPT of any metal. So sulfide PPT of silver will be Ag2S, and this shall act as your black PPT. Further H2SO4 is produced. So this is my black PPT, which is Y. Now, I'm not bothered with it. The question is asking me this white PPT when treated again with this. That means this is excess. So, sir, excess of the thiosulfate ions will bring silver, keeping the same oxidation state, but will make a soluble complex because these D block cations have empty orbitals, and those empty orbitals will allow this Ag to have more of the anions. Actually three of one more, one it is already having, and one more it is accompanied, and one ion is having 2 minus. So overall I have +1 oxidation state of silver and -4 of this, so overall charge will be -3, and because of formation of this soluble complex, which the question is mentioning as Z, the precipitate gets dissolved. So what will be your answer, sir? Option C. A very practical question, a very predictable question for inorganic as well. I hope everybody is clear with this. Moving to the next question. Chalo beta. Again a single correct. I'll not be giving you much time. Your time starts now. Come on. Come on, attempt this one as well, beta. The D block logic again. The D block logic again. Okay. Silver boys. Beta, perfect. Why is silver sulfate? Yes. Silver sulfide. Silver boy, silver sulfide. You have written silver sulfate. So I hope you are not saying silver sulfate. It is silver sulfide. Chalo. Quick, everybody. Nahin beta, nobody is nothing. Silver boy, nobody is nothing. Just keep on working, and what you are doing now is perfectly great. The thing that you are doing right now. Chalo, most of the students are answering. Perfect. So I hope you have got. Okay, less number of students have given answer to this question. Chalo, let us explore this one, beta. Here chromium is in +3 oxidation state. It is reacting and forming the yellow color chromate ion, where chromium is in +6 oxidation state. This chromate ion is converting into dichromate ion, where oxidation state is again +6. Similarly, I have these manganese. Manganese from +4. The ore first forms manganate ion in +6 oxidation state and forms permanganate ion in +7 oxidation state. But here we are asked about its color. Sir, Cr2O7 is definitely a green colored compound because chromium in +3 oxidation state is definitely green. Sir, this chromate ion you have already told us in the previous slide, in the previous, I guess, two questions before, it is a yellow color anion, and this is definitely an orange colored anion. So out of these three, only this one is, that means first is green. So first is green. Now, sir, this is a ore, a brown color, a dark colored ore. So no, sir. MnO4 2 minus, sir, MnO4 2 minus is also green in color. Again, sir, NCERT fact, sir. And this is this permanganate is beautiful dark colored purple color compound. So here also only fifth one is green. So option D is your answer. Yes, but sir, there is no predictability. Haan beta, for this you have to learn your NCERT, and learning NCERT will require revision, and that is what revision of the important block chemistry logics we are doing, है ना? Chalo. So the green species, perfect. Silver boy is acting very, very, very in a beta. Perfect revision is only done once you are working like this boy. Silver boy, hats off, beta. Perfect is what we are looking. Perfect, beta. Silver boy, perfect. Chalo. Moving to the next question. Again, it is an integer type question for you guys. So let me give you 1 minute for this question. Again, a very probable question, beta. Please read it properly. A very probable question, a very interesting question to revise block chemistry. Please read the question properly. You have to give the number of reactions which produces oxygen gas. So with such reactions, I am coupling block chemistry logic for you. Chalo. Perfect. We are over flooded with answer. Perfect, beta. Now let us see how many have given. Acha, time is still left. I'm stopping the poll. Chalo, still good, beta, good. We are having serious participants with us, so good. Answer is 4. Let us check why it is 4. Now, the question says the number of reaction giving oxygen. Sir, again, we have to know it. Do we have any predictability? Yes, beta. Common sense, I mean, not exactly, but yes, common sense will help you a bit. What is the most stable oxidation state for lead? Sir, lead is carbon family. Kashi gaye Shankar Parvati. Kashi gaye Shankar Parvati. As in, sir, lead is the last element. It belongs to 6th period. And because it belongs to 6th period, that means because before filling of lead, the very first time, the F block elements are also filled. So the Z effective, the effective nuclear charge of Z is very high, of this Pb is very high, which is nuclear charge minus shielding because of filling of D and F electrons all. So because of such high effective nuclear charge, the nucleus of lead is so strong that it will not allow the inner shell electrons. Now, what is the outer shell for carbon family? So the general electronic configuration is NS-NP, NS2, NP2. So for lead, it will be 6s2, 6p2. But the energy difference between 6s and 6p will be so huge because S and P has energy difference, but 6s and 6p, in case of the heaviest member, the 6th period element of all the p block elements, they have such high effective nuclear charge that these 6s electrons are not even allowed to participate in bonding because they start to behave as inner shell Electrons. And why do they behave as inner shell electrons? Because the nucleus is so strong that they have attracted those electrons to such an extent that they are not allowed to participate in bonding. So what is the actual number of valence electron? Only NP electrons. And how many NP electrons this guy has, sir? It has only 2 NP electrons. So what will be its most stable oxidation state? Not +4 but +2. Yes, down the group metallic nature increases, but stability of group oxidation state -2 increases down the group. This is your famous inert pair effect beta. I am telling you all the time, one of the inorganic question is involved with this, but yes, coupled with NCRT logic as well. So we know most stable oxidation state for lead is definitely +2. Now, once we react lead nitrate, we are going to get the lead oxide, because sir, +2 and -2 will form a super strong lattice. So lead oxide will be produced. Apart from preparation of lead oxide, whatever nitrogen you have, it will be released in form of nitrogen dioxide, the brown color gas. And yes, apart from this, oxygen gas will also be produced, because all the nitrates, chlorates, all the anions which is having excess of oxygen on thermal decomposition, they definitely produce oxygen gas. So here you can have oxygen gas produced, but I have given you the complete details as well. Now, so lead oxide, sir, you have already told us lead is in +2 oxidation state, but yes, we are now forcing the reaction to take place. So mixed oxide, that is Pb3O4, will be produced, and hence here there will be no oxygen, because lead is forced to attain that oxidation state. So all the oxygen present will be consumed by lead to force lead in +2 oxidation state to actually transform in some other oxidation state as well. So a mixed oxide, and because of the formation of this mixed oxide, no further oxygen is remaining, so this will not form. Yes, sir. Again, lead oxide with nitric acid. So nitric acid is an oxidizing agent. Nitric acid is an oxidizing agent, and this oxidizing agent can't oxidize lead in +2 oxidation state. Why? Because +2 oxidation state of lead is stable, and therefore lead will remain in +2 oxidation state and will rather just form a salt. So lead nitrate will be formed, and yes, water will also be produced. So here also there will be no production of oxygen. How can you predict? By knowing through inert pair effect that +2 oxidation state of lead is stable. So you can predict also, else it's a fact. Now, yes, sir, I have lead in +4 oxidation state. Answer, you have already told us that for this +2 is more stable. So +2 oxidation state will be formed, because all the remaining oxygen gas will be released. So this can also be very easily predicted. I hope everybody is with me on this. Now, what about the remaining, sir? PbO2 plus HCl, cold and aqueous. Sir, halogen form logic. Lead has empty orbitals as well. So a beautiful complex will be formed. And that complex, because of the formation of that complex, all the species will be inside that coordination sphere. So here also no oxygen is formed. Now, sir, PbO2 with H2SO4, what this is going to produce now? Sir, lead is again in +4 oxidation state. So it will try to come in +2 oxidation state in form of what? In form of lead sulfate plus water. Yes, here also oxygen gas will be produced, because this PbO2 having excess of oxygen will be forced to throw that oxygen out to come in +2 oxidation state. So this can also be predicted as well. Now, last one, so this we already know. This is again, that was a higher oxidation state lead. This is a mixed oxide, which is Pb3O4. It will definitely form lead in most stable oxidation state, which is +2. And this also has to throw oxygen to bring lead into lower oxidation state. So this will also be an answer. So how many of the reactions are giving you oxygen gas? Actually 4. But this is not a question for oxygen. This question we are cracking through the chemical bonding logic of inert pair effect. I hope everybody is clear with this. Chalo, perfect. Moving to again beta, I guess this is also a multiple correct. So I am giving you again a minute, because again it's a multiple correct question. Please read the question properly, guys. Please read the question properly. Just try to read the question properly. Good. Good. Just try and read the question properly. Which of the following reaction are possible? How many of them are possible is your question. Molten tin reacting with chlorine forming SnCl4. Yes, sir, chlorine is in excess. So excess will force tin to come in +4 oxidation state, because inert pair effect is valid for lead, for the heaviest member, not for tin. Beta, please make sure, what is the most stable oxidation state for Sn? +2 or +4? +4, because inert pair effect is valid for the heaviest member, the 6th period element, because 6th period element will be having very high Z effective, because actually F is filled. F is firstly filled after in the 6th period. So tin is a 5th period element. So inert pair effect is not applicable for tin. It is largely applicable for lead. So for tin, what is most stable oxidation state? That is what I'm doing, Bhumika. That is what I'm doing. I have read your comments and your wishes are command, and that's why I have initially used inorganic logic as well, because I was seeing this. That's a formula revision. So beta, see, formula revision as in for chemistry, inorganic revision is the formula revision, because obviously organic you get mixed questions. I'll be dealing with organic questions, but you'll be getting questions based on the basis of reaction mechanism and your knowledge of NCERT. Your knowledge of NCERT is not point blank going to help you. Again, in physical chemistry, the NCERT logic, the just knowing the formulas are not going to help you. It will be combining topics of mole concepts and electrochemistry combined with ionic equilibrium. So obviously you have to be sound conceptually. So what is the formula revision for chemistry? Inorganic. So inorganic, that's why I've brought initially. Okay, people are answering as well. AB. Perfect, beta. In multiple correct question, you should always answer at least those questions where you are more confident. Actually, here, ABC is the answer. So C is given by very less number of students, but still, I guess, let us explore why ABC is correct. How many are possible? Sir, here tin is in zero oxidation state, because chlorine is in excess, so definitely tin will be oxidized to the maximum stable oxidation state of tin, which is definitely +4, so this is correct. Sir, aqua regia is 3 parts of HCl and 1 part of HNO3, which is a species which has a capacity to make soluble complex of all the possible even inert metals like silver and gold. So tin also has got no capacity, so tin will also come in its maximum oxidation state, which is +4, stable oxidation state, which is +4. Yes, and NO will be produced. This NO further acts as a ligand and forms the soluble complex of even the inert metals. So yes, sir, this is also definitely correct. Now again, sir, you already told us that for tin +4 oxidation state is most stable, but now I am forcing, like for example, if you want some SnCl2, like for stiffen reduction, what is the reagent for stiffen reduction, sir? SnCl2. So for industrial reactions, sometimes SnCl2 is required, sir, but SnCl4 is stable. So how to form it? The method, the industrial application to produce SnCl2 is use SnCl4, in which tin is more comfortable, but once you add tin granules, so the tin granules will induce the reaction to force +4, because this tin will try to form Sn+2 and this tin will be forced to form Sn+2. So percentage existence of Sn+2 will be increased. But yes, this is a forced reaction. And obviously the tin granules will keep on getting finished. So you have to put them again and again. So industrially SnCl2 is produced via using tin granules with SnCl4, which will force the production of SnCl2. A very important logic, beta. A very important industrial logic also. So C is also correct. Chromium +3 and tin +4. Sir, you have already told us Sn plus 4 is more stable. So because it is more stable, so forward reaction. Because here you do not have any catalyst. This is just a spontaneous reaction. Nobody is a catalyst. Even for chromium, plus 3 has a stable half-filled configuration. So chromium also wants to be in plus 3 oxidation state. So there is no catalyst. Like here, metallic tin is acting as a catalyst. But here there is no catalyst. So this reaction is not feasible. So A, B, C is your correct answer. I hope everybody is correct. I hope everybody is in sync with me. Pleasure. Chalo. Perfect. Chalo. Moving to the next one, guys. Attempt this one. Again, a multiple correct. I don't want you to answer incorrectly. Maybe give less number of correct questions, because obviously you will be having partial marking, beta. Obviously you will be having partial marking. So I am very much happy if you are attempting not all, but at least do not attempt wrong. I'm definitely assuring you that IIT Roorkee, whenever sets paper, they always give partial marking. So don't worry. Chalo. Good. Chalo. Please attempt, beta. Please attempt. I'm allowing you to time to read the question, because the most difficult part is actually to read. Students don't find it comfortable in reading the question properly, beta. So you are very much supposed to have a habit, have a practice of reading the questions. Here all the options are correct. Obviously you will not be getting such questions. You will be obviously having ABC max, because they want you to attempt it incorrectly. Only one. Chalo, nobody, no worries. Let us explore the question, beta. Which of the following reactions are possible? That means how many of the reactions are correct? We just have to find the correct reactions. So copper produces copper plus 2 and NO with dilute HNO3. Remember block chemistry logic. HNO3 generally, obviously it is a oxidizing agent also, it's an acid also, but it oxidizes other and reduces itself to what form depends upon the concentration and temperature. Concentrated nitric acid with all types of metal always produces NO2, but dilute produces different reduced form of nitrogen, because it is an oxidizing agent, so nitrogen itself will get reduced. A trick to remember, a mnemonic to remember: if you have read the electrochemical series from your electrochemistry or from your class 10th, sir, less reactive metals, let's say I am making electrochemical series downwards. For example, the more reactive metals are coming on upside and the less reactive metals are coming on downside. The more reactive are coming on upside, the less reactive are coming on downside. So whoever are coming on upside will form what oxide of nitrogen? Nitrogen in least oxidation state, which is nitrous oxide, because here nitrogen is in +1 oxidation state. The next higher oxidation state of nitrogen is nitric oxide. So this is the way I make my students learn. How? Sir, this is upside, this is downside, because nitrogen +1 oxidation state, you have to write up and then down. Most reactive metals up, less reactive metals down. So with most reactive metals, what oxide of nitrogen is formed? Nitrous oxide. With less reactive metals, nitrogen forms nitric oxide. Now what about copper, sir? Sir, we definitely know, all of us definitely know that copper is below hydrogen. So it is more reactive or less reactive? Sir, less reactive. That means what oxide it will be forming? Sir, NO. So it will be definitely forming NO, and copper will be getting oxidized to copper +2. So definitely this is correct. Again, silver produces, but sir, this is concentrated. So concentrated will always produce NO2 and the metal will get oxidized. So this is also definitely correct. Now, I2 produces HiO3 because again sir, concentrated nitric acid. So first I2 is oxidized by nitrate ions in its oxidation state, which is I2O5, the oxide of nitrogen. And this oxide of nitrogen on hydration, because obviously water will be there, will convert this into HiO3, which is HiO3. What is the oxidation state of iodine over here? So here also it is in +5. So further the oxide undergoes hydrolysis and form the corresponding oxy acids of iodine. So this is also correct. Zinc produces Zn+2 and because now they are not using concentrated or dilute, they are using very dilute. So again sir, HNO3 is an oxidizing agent. It will oxidize other and it will reduce itself, but in what form depends upon the condition, the temperature, the pressure and the concentration of nitric acid. If you have very dilute nitric acid, then with zinc obviously the metal gets oxidized, but nitric acid will not change its oxidation state, because zinc with HNO3 will be forming ammonia. Ammonia will be produced, so ammonium hydroxide, but ammonium hydroxide is a base. Remainder of HNO3 is an acid, so very dilute acid as a very less number of acid will also react with ammonium hydroxide, and that ammonium hydroxide will further produce ammonium nitrate, because ammonium hydroxide with little amount of HNO3 will form the corresponding salt, which is ammonium nitrate. So obviously this is also your correct option. So all the options are correct in this question also. Why you are giving such questions are to at least make you learn NCERT, and I hope you guys are revising also these things with me. Chalo beta, a single correct, 45 seconds for this one. Try and attempt this one beta. Read the question properly. A doable one, I guess. A doable one, I guess. Ha, laughing gas. Final revision of all formula. Beta, Bhumika, I answered that beta. The reason I'm taking more of inorganic initially is because these are the formula things. Rest, organic and physical, there is no formula as such beta, because this is not a JEE mains question paper. You have to be vigilant with your mechanisms of organic, with your logics of physical chemistry, then only you are going to attempt your JEE advanced question. But yes, inorganic can be attempted quite easily if you remember certain facts. So, but sir, all the block chemistry logic I cannot read, so at least I have filtered few questions for you. है ना? चलो बेटा, try and attempt this one. I guess time is done, and I guess few of you have got answer as well. Now, none, no worries. Let us revise this. Now, question is saying ammonia is burnt in air at elevated temperature, platinum as catalyst, and at high pressure. So, sir, ammonia oxidation state of nitrogen is -3. Obviously, with atmospheric air, this nitrogen is bound to undergo oxidation, as an oxidation state is going to increase. Sir, we know that the preparation of nitric acid, what is the stable oxide of nitrogen which is produced via catalyst? This you know through NCERT only. Sir, nitric oxide is formed. So NO is your desired gas. How the predictability is coming? Through the preparation of HNO3, which is already given in NCERT. Now, it is passed into SnCl2. Sir, here tin is in +2 oxidation state. Sir, for tin, what is most stable oxidation state? +4. So tin will definitely undergo oxidation. Because it is going oxidation, so it will try to reduce nitrogen now. So what reduced form of nitrogen you can have, sir, but there is solution. So there is aqueous solution. So if at all you're producing, if you're thinking ammonia in your head, then you have started with ammonia. You cannot produce ammonia at the end, because the amount of money you're putting into the catalyst, you have to get some product to sell your, to make your factory function. So actually the hydroxide version of ammonia, which is ammonium hydroxide preparation, it is an intermediate step of the further preparation of nitric acid. So the intermediate step will bring ammonium, will bring you hydroxylamine, and that hydroxylamine will be your answer. I hope everybody is clear with this. Then beta, Silver Boy is asking, sir, what if you do not, beta, if you do not use the catalyst, then you can't force nitrogen to attain a higher oxidation state. You can't force nitrogen to attain a higher oxidation state. So generally we require, because actually the contact, the process that we actually use industrially to form nitric acid, we generally force the atmospheric nitrogen. The atmospheric nitrogen is a most stable diatomic molecule, because bond order of N2 is 3. So that's why catalyst is required. Once we have employing those catalyst in air, so because we employ that catalyst, so we have started using that catalyst n number of times. So this is just permutation and combination beta, through which the industrial community and the scientist community have came into a picture that this can be used as a catalyst, and hence its use is intensified these days. This is just like the trick by which we have got that corona vaccination. So these are just hit and trial methods, but yes, because they have been patented and NCRT makes you write them, so that's why JEE also finds interest in them, है ना? Chalo, perfect. So I hope we have the answer for this also, which is hydroxylamine. Again, हाँ बेटा, question to revise oxy acids, a chemical bonding logic as well. So an integer type question for you. I'll not be giving you 1 minute for this, 45 seconds. Please attempt beta. How many of them have oxo group and element bond O bond H? Element bond O bond H and oxo group. Try. Try this one beta. Four, perfect. I just love the level of participation beta. So happy. Very good. At least you are reading questions. Ah, very good, Silver Boy. Very good, Sudha. Very good, Kevin. Very good, Gruken. So actually, the Anand, the reason I'm happy is because you guys are reading questions beta. 90% of the job is done once you are reading the questions properly. I guess 3 is my answer. Let us see why. Few people are answering 4. I have no problem with you answering incorrectly, but I am, yeah, Adi boy, yes, 3 is your answer, not 4. Why? Let us explore beta. Sulfurous acid. What is sulfurous acid? So this guy is having lone pair, one OH, second OH and oxy group. So this is nothing but H2SO3 is sulfurous acid. So is it having the oxy group? Yes, sir. Is it having element OH bond? Element OH bond? Yes, sir. So sulfurous acid is an option. What is arsenous acid? Sir, arsenic. Whenever we have arsenic, the nitrogen family, New Zealand, Pakistan, Australia, sub bikau. So nitrogen family guy will be having 3 OH, and because it is a nitrogen family member, so it will be having one lone pair. No oxy group. It is having O bond H linkage, but because of no oxy group, C double bond O, this arsenous acid is not an option for you because it is not having this oxo group. Sir, hypochlorous acid, everybody know this is HOCl. Here chlorine is in +1 oxidation state, so obviously there is no oxy group. Yes, it has OH but no oxy group. What is perchloric acid, sir? The famous oxo acid HClO4. So we definitely know not one, it has many double bond O and OH also. So this is my second option, which is having both of them. Sir, peroxo nitric acid, sir, nitric acid we know it is HNO3, but peroxo, so I will do what? The lone pair of nitrogen, let's say it is getting coordinated. So a double bond O, lone pair will be coordinated to O, and this will be OH. But I need to create peroxo, so this is a peroxide linkage. So this is HNO4. Now it is having a oxo group, but no N bond O bond H. This is peroxo, so N bond O bond H is missing. So this is also not an option for you. Now last is pyrosulfuric acid. This is H2S2O7. The reason I'm taking this question because I want to make you revise the famous block chemistry logics. So this is H2S2O7. It is having oxo group also, loads of them, element bond O bond H also. So this is also an option for you. So answer for this question is 3, not 4. I hope everybody is clear. The acids that satisfy both condition are silver boy. Peroxonitric acid is not an option. I did. Chalo, perfect. I hope everybody got it. Chalo. Okay, perfect beta. Perfect. No worries. Chalo. It is not peroxonitric beta. Chalo. I hope everybody got the question properly. Chalo. Again, a question which will require your reading time, but a easy one. So please attempt this easy one, beta. Try. We have anhydride of B and F. They act as strong dehydrating agent. This is given in the question. You have to give the chemical formula of E beta. We have done a question of this sort. Yeah. Yes. It's POCl3. Come on. Very good. So a single correct one. Yes, you have to read through a lot of logic, but good. Proud of you people. Chalo. If okay, let us work on the flow chart. Sir, white phosphorus is P4 having that angle strain. And because of that angle strain, if I have thionyl chloride, I'll be the question is also giving you a hint through chemical bonding. It is trigonal pyramidal structure. So who has got trigonal pyramidal structure, sir? Phosphorus in +3 oxidation state chloride, so PCl3. So this is trigonal bipyramidal, so this is PCl5, although this is an NCERT fact also, that sulfuryl chloride brings phosphorus in +5 oxidation state and thionyl chloride brings in +3 oxidation state. On complete hydrolysis, sir, phosphorus will remain in the same oxidation state, so it will be forming POH, OH. That means H3PO3. This is phosphorus acid, which is the oxy acid. Now, what else, beta? PCl5 on heating considering this PCl5 to be in gaseous state, on heating the two chlorine which are axial will be broken and Cl2 gas will be produced, resulting in the formation of PCl3. So because of the homo-lumo transition, remember the advanced question, why halogens are colorful although they are diamagnetic? Because they have homo-lumo transition. So because of that homo-lumo transition, its color is also mentioned, which is greenish yellow. So done. Now, this PCl5 on complete hydrolysis, obviously it will form H3PO4, the phosphoric acid, but on partial hydrolysis, it will be forming POCl3. So these are all the details, but we are only supposed to give answer that what is E. So E is definitely phosphorus oxychloride for us. So yes, a doable question, but yes, I've given you this question to make you revise NCERT. Chalo. Perfect, guys. Perfect. Moving to the next one. Try and attempt this one, a basic of mole concept. So giving you 30 seconds for this one. Single correct. Very doable question, beta. Very doable question involving logic of inorganic chemistry with little bit mole concept. Not even mole concept, beta. Stoichiometry. Come on. Come on. Shoot. Shoot with the answer. Yes, Anand. Perfect. Yes. Yes, I. Yes, Amu. Perfect. Amu, hello. Sir, I work for Gate. Beta, Gate. Huh, beta, if NCERT is your thing, so yes. But I mean, yes, I haven't seen those PYQs lately, so if NCERT is a reference for you, so definitely these are all good NCERT facts, famous NCERT facts. Chalo. So we are overflooded with answer, and yes, this is definitely C. I wanted 100% participation with 100% students giving correct answer, but no. So I hope you have not read the question properly, because this is quite doable. Ozone, which is not a very stable form of oxygen, will try to stabilize itself as oxygen gas. Stoichiometrically, it is class 10th thing that 2 moles of this will be producing 3 moles of this. Question is asking you final volume of gas, so you have to think of the stoichiometry of ozone as 1. So 2 produces 3, so 1 will produce 3 by 2. So 3 by 2 times will be produced. For keeping advanced question in mind, beta, this is what advanced do it a few times, because back in your mind you think it advanced. Such questions come, and what do? You think more. Search for easy and moderate questions, finish them ASAP, and then go for good questions with good temperament. But yes, in order to identify, the question will not dance in front of you and will say, I'm easy, that you have to read. So that's why the most important part is you reading the question properly. Hai Chalo. So that's why I have intentionally put this easy question in between. Chalo. Again, a single correct one, beta, giving you 30 seconds for this. Shoot. 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 Perfect. Shoot. Tailing of mercury. We know mercury is a metal which at room temperature exists in liquid state. And the adhesive force is also very nominal. Cohesive is large, so there is no sticking of mercury with the walls of the container. But whenever this mercury is introduced with a strong oxidizing agent, so oxidation of mercury takes place. So oxidation of people are answering also. Perfect, beta. So oxidation of mercury takes place. And which is the famous oxidizing agent which you can see over here, sir? Ozone. Perfect. Still, I have 30% students answering correctly. So as I was saying, once you have ozone, ozone will produce nascent oxygen, and this nascent oxygen can oxidize any and everybody. So whenever mercury, which was quite a liquid which is having no adhesive force, the fluidity of this liquid is super awesome, so it does not stick to the walls of the container. But as it gets oxidized and it gets oxidized to mercuric oxide, so the fluidity of the liquid mercury starts to lessen, and as it gets lessened, so it starts to have adhesive adhesive force with the walls of the container, and that brings the tailing. You can visually see mercury sticking to the walls of the container. So this is known as tailing of mercury, a very important point. So option B, a logic also, a chemistry in everyday life thing also, and definitely a common logic from P block elements. Moving to the next question. Now it's a multiple correct question, so I'm giving you 45 seconds for this. Shoot. Shoot, beta, shoot. Again, now this is entirely a check, a test of your preparation. Alkali metals, most of the logics I have taken is for P block and D block, not of alkali metals. For alkali metals, the most important, I'm just closing inorganic with this beta, because you must have observed the trend. First we have taken the block chemistry logic of DNF block, after that we have taken important logics of P block, and now we are coming to D block. So now we are coming to S block, I beg your pardon. So for S block, what is the famous block chemistry logic? With few questions I'll be discussing. The very first thing which you should remember is also a topic from your practical, from your qualitative analysis, which is flame test. So B, yes. So flame test, because alkali and alkaline earth metals have free electrons. So those electrons are excited in visible light, and whenever they are excited in visible light, they give color, and with the color that they induced in their flames, they can be identified. So very important colors, beta. Obviously over here, barium, strontium will be red, and LiCl will be red. So B and D will be your answer. Sir, you beta, this color you obviously have to read. Sir, can you give me this PDF? I'll be definitely giving you. In alkali metals, lithium is crimson red, sodium is yellow, potassium is violet, less violet, so some people call it pale violet, less intensified violet. This is sometime reddish, sometime violet, rubidium. This is bluish violet, cesium. Calcium is brick red, strontium is cream type of red, as in not intense red, and barium is definitely apple green. Sir, what about alkali metals which are beryllium and magnesium? Alkaline earth metal have stable electronic configuration because it has fully filled configuration. It is Ns2. And the smaller elements, the smaller the group 2 elements, because beryllium is not an alkali metal, so beryllium and magnesium, because of small size, their ionization is quite high, so the excitation do not take place in visible region, hence they do not give flame coloration. But yes, the other alkali and alkaline earth metal gives, and it is very important. It is very important. So please learn these colors, beta. I hope everybody is good. Chalo. Moving to just few, then we are just moving to organic chemistry after this. Just few more logics of S block. Among the following, the diamagnetic compound. So again giving you multiple correct, so again giving you 30 seconds for this. Attempt this one, beta, just 30 seconds. Attempt this one. At least read the question, because without reading you are not going to land anywhere. Reading the question will actually help you do the question 50%. So you have to say that when CO2 reacts with water, what is the product produced? Chalo. When CO2 reacts with water, what is the product produced? Acha, that is the next question, beta. This is just diamagnetic compounds. Okay, this is just asking you about diamagnetic compounds. Okay. So here I guess among them, what are the diamagnetic compounds? Sir, we definitely know ozone. Yes, oxygen is paramagnetic, having those two unpaired electrons. But once that oxygen donate those unpaired electrons to another oxygen, this ozone becomes diamagnetic. This we can obviously say through VBT, not even MOT, because MOT we only have for homonuclear diatomic molecules. So this is definitely diamagnetic. This nitrous oxides are N, triple bond N. Definitely this lone pair will be coordinated to this oxygen. So this also will have no, through VBT we can say this will also have no unpaired electrons. So this is also diamagnetic. Sir, potassium is in +1 oxidation state. So this is O2 minus 1. So O2 minus 1 is actually superoxide. So this superoxide will definitely have one unpaired electron because oxygen has two. So because of one unpaired electron, it is paramagnetic, so not an answer. And here this is sodium, so this is O2 2 minus. So this is peroxide, and peroxide both the electrons are paired, so this also becomes diamagnetic. So A, B, C. I guess over here you have A, B, C as your answer. So A, B, C among them are diamagnetic. Less percentage, but still good beta. Good, at least you people are trying. Now, this is the question I was talking of. Actually, beta, a very famous, which I feel advanced is definitely going to ask you. Lithium form oxides, sodium form peroxide predominantly, and remaining alkali metals produces superoxide. Why? First question. Why? Because these oxides are solid, and an ionic solid is produced once we have comparable size of cations and anions. Lithium, being the smallest cation, prefers to form a better solid, better lattice with oxide, because oxide is smaller, it is just monatomic. Superoxide and peroxide are molecular ions, so they are large, where peroxide is relatively large, so it forms a better solid with sodium, and remaining large alkali cations make efficient solid, efficient lattice once they form superoxide. I hope everybody is with me on this. Now the question is asking us, when KO2, which is definitely a Cu superoxide, when this KO2 is dissolved in water, sir, it definitely forms hydroxide along with H2O2, and because this is a superoxide, so having excess of oxygen, so oxygen gas is also produced. If I have a peroxide, then this peroxide with water will just produce the corresponding hydroxide and H2O2, because it is not having excess of oxygen, so this oxygen is not there. And if I had lithium oxide, then lithium oxide with water just produce lithium hydroxide, nothing else. So obviously here, not these things are not asked out of you, but again a very important S block logic, hence serving you with this. Give multiple option poll. Ha beta, I have not given poll for this one because I'm just trying to come to organic chemistry now. So KO2 will definitely form KOH, option 1, H2O2, option B, and oxygen, option C. Not this one. So A, B, D will be your answer. I hope everybody's actually now, as a student, even I didn't like inorganic. We'll not say this outside, but as a student, my JEE rank was, my AIR was somewhere around 6,000. Because in my time, there were only 6 IITs, so I got into NIT Kurukshetra. But I hated. I'm very sorry, SPR sir, because he was my chemistry mentor. I just took a drop of 1 year and I cleared JEE. SPR sir, I'm very sorry, but yes, you taught inorganic. That was my bad. I loved physics. There is a whole different story why I'm teaching chemistry. But yes, I didn't like inorganic at all. So moving to organic and physical, obviously we love organic and physical. But inorganic is easy. But yes, you have to keep on practicing inorganic, not on a single stretch, because everybody gets, you understand. So let us go to organic and chalo. Let us go to organic beta. Attempt this one. A very good question for organic. I have brought you limited questions, but those limited questions will help you to practice complete organic. So we have to work on each options. I'm not giving you time. We are working on it together. So let us explore the first option first. The question is saying which one does not represent the correct product. So obviously we have to check each option. So let us first check the first option. Come on, shoot. Shoot. Shalini, Beta, the questions which I'm having right now, na, they are much crucial and critical than multiple correct. You just work on each options is what I'm telling you. Ah, smart guys. I mean, I'm not interested in answer at this point of time. Ah, yes, due to steric hindrance. Ah, yes, silver boy. Perfect. Now, actually, what condition I have? I just have to make hydrogen react with 1 mole of hydrogen under heated condition. Now, what options I have, sir? I can either make hydrogenation of this double bond or this double bond. Now the double bond which is outside, sir, because this is a conjugated alkene, so the pi sigma pi conjugation will also be there. So because of that pi sigma pi conjugation, this ring is locked. And sir, we also know that this is a 6-membered ring which is free from any types of angle strain. So which exo or endo? Exo as in the double bond which is outside the ring, endo as in the double bond which is inside the ring. So the double bond which is inside the ring which will be stabilized, because 6-membered ring do not want to break itself because it has 0 bare strain. So obviously the hydrogenation will be taking place outside, and this carbon will be getting the product form. If at all there would have been just a conjugated alkene, if at all there have been just a conjugated alkene, no cyclization, then here what is going to be happen? If I have 1 mole of hydrogen, then in that case, sir, because you have excess of temperature, so free radical can take place. So 1 hydrogen will be getting added over here, making a radical here. 1 hydrogen will be because this can rotate now. So 1 hydrogen will be getting added here, making a radical here. So it will have chain termination. So a double bond will be coming like this, and a saturated compound of such sort will be formed after chain termination. But here the product formed is different, because this was a open chain product. But here you have the chain which is least hindered, bare strain is 0. That's why exo group will be reacting, and only this alkene will be hydrogenating and form the corresponding alkane. So definitely this is your correct conversion. Question is asking you which does not represent correct product. So because this is correct, hence not an answer. I hope everybody is clear with me. I'm actually stuck within A or C. So silver boy, everybody, I hope everybody is clear with option A. Chalo. With these questions, beta organic, put down your pen, just take out your rough copies. I am not interested with answers. I want explanation of each option, and that I'll be doing. But I want you to come in sync, because whatever logics we'll be using will be NCERT logics, but that NCERT logics will be marrying, will be having a friendship, a strong bond, a strong friendship with mechanism. And what is mechanism? Sir, GOC logics, stabilities, reaction intermediates, electron displacement effects, and this is all what advanced want out of you, that learn all those logics of NCERT and use your brain using mechanism around it. What is mechanism, sir? Attraction of plus minus. So what is reaction mechanism? Sir, minus attract plus. Plus is what? Sir, nucleus do not react, or else there will be Hiroshima, Nagasaki. So who move? Electron. Electron move from where? From higher concentration towards lower concentration. This we know through physics only. So the logic of reaction mechanism is nothing but plus minus attraction. I hope everybody is clear with me. Moving to the next option. So option A is not an answer. Option B, sir, we do not have to move our pen. It is quite doable. How? Just check. Now, sir, this is a bridged head carbon. Sir, no substitution takes place at bridge head carbon, because it will break the ring. Hence, bridge head carbon, this bridged head carbon will have no substitution. Hence, this chlorine and this chlorine will be as it is. So I'm happy. What about these chlorine? I'm making with different color. This chlorine, and these two chlorine. They can easily undergo SN reaction. Why? Because I have aqueous KOH. Chlorine, being a good leaving group, will leave, and OH will be substituted. So these two chlorine will be getting those corresponding OH. These two chlorine will be gone and I'll be getting corresponding 2 OH, but one carbon having 2 OH, that is geminal diol will dehydrate and corresponding carbonyl group will be produced. So this is also I'm happy. Now, sir, they are resonance stabilized, vinylic, so partial double bond character, and because of partial double bond character, these bonds are not going to break, and therefore these chlorine will also remain as it is with no substitution. That means this is also correct, sir. And because it is correct, so not an answer. I hope everybody is clear. I hope everybody is clear. Ah, yes, creative. Yes, smart guy. For D, cyclic silver. Aye, hi, very good. Ah, perfect, perfecto. Chalo. Moving to option C, sir. Every option is an independent question for us to learn, and that is what we are doing. Break for 5 minutes. Beta, no break, yaar. Sunday you have your paper. I'll be just finishing in another half an hour. Half an hour, maybe 30-40 minutes. No break, hai na, please. I also see. I have finished coffee. This is the first bowl. Water also is finished. Now this is the last glass of water I have. So at least even I am speaking. Give me 30-40 minutes more. Chalo. 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 Sir, this question, hai na? Sir, this is organometallic compound. Alkali metal and CH3 minus. Sir, this CH3 minus will be searching for plus. Reaction mechanism. So nucleophile, sir, where I have plus, beta I have plus here, beautiful plus. So this minus will come and will kick one bromine. So one bromine is lost in form of Br minus. Okay, sir. What about the intermediate? Then you will be having 2-methyl this way, 2-methyl this way, one bromine like this, and a methyl group like this. The CH3 is just introduced. Now, as soon as I have got this, again, what is bound to happen, beta? Sir, again, because of presence of, I hope everybody can see that once this is gone, this CH3 minus will be coming and will be attacking over here. As soon as the attack has taken place, beta, Acha, वैसे you know what is the point? This bromine will be leaving as Br minus with Li plus, right? So I will be getting one methyl group over here, no worries. This is CH3 Li. Just check the regioselectivity of this, beta. Just check the regioselectivity of this particular option. Because I guess with your NCRT also, acha, I just need, let us do it in a fresh page. Let us do it in a fresh page. I have this cyclic compound, okay, sir. I have this geminal dihalide, okay, sir. And I have this organometallic compound. Okay, then beta, you have to be then switching to your NCRT logic also over here. You know what? Sir, formation of vicinal, when you have vicinal or geminal dihalides, they undergo dehalogenation. Remember, I am giving you a trick. I am giving you a common sense through NCRT fact. Because obviously, few of us will think, sir, because this is minus and because this is plus, so this nucleophilic substitution shall take place. Why? Because sir, this is a 3-membered ring. 3-membered ring is hindered also. Whenever this minus will come, these large bromine, will it allow the nucleophile to easily accommodate? No, sir. And backside also attack cannot take place because both of them are tetrahedrally surrounding this this highly sterically hindered. Bayer strain in cyclopropane is also high, so the ring also wants to open itself. So and one more help from NCRT that you can get is vicinal and geminal dihalides undergo dehalogenation, as in both the halogens are removed. And if you remove both the halogens, now if you know such certain facts, then you will definitely not try to do this which we were doing in the previous case. So instead what you will try to do, sir, instead of that, we'll try to have these bromine and because of presence of that organometallic compound, which is LiCH3, one bromine will be gone. After this bromine is gone as Br minus, another bromine can also be removed. Sir, how? Because this minus can give electron to this Br actually, because this is not hindered, and because this is not hindered, and if this minus is giving electron to this bromine, so a anion, a intermediate where electron richness, let me create that electron richness, this can be produced. I hope everybody is with me on this. Now this minus will help, the hindered ring to open up. How? So this minus can go here. Once this carbon will be gaining the extra electron, it will not be requiring bond of this hindered carbon. So this bond can move. The double bond has taken minus. Okay, so let me transfer this bond from this carbon to this carbon. Which one? From this carbon, let me transfer this minus from here till here. The moment this bond is broken, who will get the extra electron? This guy will get the extra electron. As soon as this guy has got the extra electron, because the ring is also opened, so that means, let me just do it the first step first. So this was a sigma bond. Sir, this sigma bond will try and be converted into a pi bond. That is okay, sir. Now look at this carbon, which is having two groups, but now it is having a substitution. So I need both the carbon to form a double bond. Why? Because once it has formed a double bond, this ring has to be broken. And how many number of bonds you can see over here? 3, na? Yes. So what is the... I am forming an alene over here, na? This is an alene. So this C, if I am trying to make this alene, then this carbon is as it is. This carbon is as it is. I need this carbon to be double bonded with both of them. And in order to be double bonded with both of them, this guy has to receive electron. This guy will receive electron once it has some extra electron. So we can think of those extra electrons like this also, beta. It has got extra electron. They have also got extra electron. So a double bond can be formed between them as per chain termination. You can think of that. Like these guys have double bonds, have single bonds. Now this electron, which is a sigma bond between them, can be associated with this carbon, which is an electron rich carbon. Minus, minus. So these chain termination can actually produce an alene. Now I'm just giving you a predictability because it's a single correct question, beta. A good one, not very easy predictability, but what I have done is after seeing the reactant and the reaction condition and the product, I am just trying to satisfy the number of electrons present. So if you just try to satisfy the number of electron presents, yes, the exact movement is not very easy to be predicted. Definitely such reactions when given in Morrison and Voigt can only be predicted, but at least you can have an idea of the number of electrons are satisfying or not. So I have done this question with an idea that this carbon once attaining extra electron, so that electron can have a chain termination with these two. For that, they have to contribute 1 electrons. For that, they will break their sigma bond and will be can form this alkene. I'm not saying this reaction will be highly spontaneous, but yes. Is the formation of this alene probable? Yes. Maybe a reversible reaction, but is this probable? Yes, sir. So because this is probable, Silverboy is also mentioning about the regioselectivity is clearly driven by steric bulk, and definitely because this three-membered ring is sterically hindered, so it will try to open itself. So this is also a predictable option, but yes, some students may find it not very convenient. So because this is a single correct, so either this is an option or that is an option. Here at least we are able to predict that it can be electronically shared and produced. Now let us work on option D. I again have a vicinal dihalide. Now here I have Ag plus. What this Ag plus is going to do, sir, it is going to make this first bromine move as Br minus. So a carbocation, a plus will be formed over here. After the formation of this plus, how many membered ring I have, sir? 5. And again a 3-membered ring, so ring expansion will take place. How? This carbon, I mean any ring can be expanded, but let us say this carbon will break this sigma bond and will bring the electron over here. As soon as this electron is brought over here, the ring has been expanded, but this carbon will now gain the positive charge. So what will be the probable product, sir? 5-membered ring. After that, this bond has been recently broken. This bond, 5th bond, has been recently broken and has been made with this carbon. So a double bond is introduced. This guy is having 1 bromine and it is already connected with this. So how many member ring I have right now, beta? Let us number it. So 1, 2, 3, 4, 5, 5 and 6. And because this 6th carbon has lost electron, so it will get a positive charge. Now, sir, this is pi sigma plus. That means that this is a resonance allylic carbocation. This allylic carbocation is stable also. So this stable carbocation will receive lone pair from oxygen. Oxygen will take electron from hydrogen, releasing H plus. So that H plus is released and OH is introduced. So a 6-membered ring with double bond at 1, 2, and that first carbon is having bromine and the next position is having an OH. So double bond, that carbon should have. So let me make that product for you. So a 6-membered ring. Let's say I have a double bond here. So this is bromine, and after that double bond, I'll be having OH here. Yes, obviously its IUPAC name will be decided from this carbon, because I was just numbering it to just make the 6-membered chain. I'm not saying it's the IUPAC name. IUPAC name will be this: 3-bromo cyclohex 2-ene 3-bromo cyclohex 2-ene 1-ol. I'm not answering. But sir, is the product same? No. So that means this is definitely incorrect. And because this is incorrect, so definitely your answer. So answer is option D, because this is incorrect and question is asking you the incorrect option. And because this is clearly incorrect, so you can have a predictability that this ring opening may take place. Hello? Hello? Good question. Good question. Beta, good question. But yes, even in your advanced examination, beta, you will be doing the first paper 1 with an awesome efficiency. What is actually going to challenge your actual JEE Advanced result is the way you are handling your paper 2. And definitely after being exhausted, after having putting your brain for complete paper 1, paper 2 will be challenging. Sir, how you can train yourself for paper 2? Please sit. Do not sit. Do not leave the session that no, I'll have a lunch and then I'll do it. Please do with a not very calm mind, because paper 2 will not give you a calm mind, and therefore you should have a practice. This is the main reason I'm stretching this lecture. This is the main reason in the initial point, in the initial stages, I've taken many block chemistry logic, because I wanted to make your brain exhaust. And after an exhaustive brain, even if we have attempted this question in the first time, no, I mean in the very beginning, we'll be doing it with very ease. Because it doesn't happen with you, it happens with teachers also. Everybody gets exhausted. This is a human tendency, but beta, practicing while being exhausted, we are still practicing. That means you will be able to deliver not best but better than today if you do the same practice tomorrow. So before your examination, try to exhaust yourself, because the more and more you practice, the more and more sharpen your efficiency will become. Chalo. Chalo, no worries. No worries, my friends. I am there for you. Chalo. We'll be finishing in another half an hour. But 15-20 minutes. That's it. Few 2-3 questions more. But I have few good questions now, beta. I have good questions now. They'll be requiring discussion. So again, my question is, which of the following does not represent correct product? Again, a single correct, but you have to check all the options. So please let us do one question at a time. Let us do one option at a time. So this is, let me not give you some time because we have to work on each option. So you just draw this first option in your copy. Nahi beta, creative, not C. D was answer for previous question. Option D. Creative. I am not saying option C is a very stable product, but yes, it may be formed. And the reason behind the formation of that product is only because of the fact that so 3-membered ring is highly bear strained, so it will rather try to open itself. Although the electron distribution was clumsy, but still it was a probable option because D can never be formed. है ना? Nahi, Manju, you cannot have segregated chapters for advanced beta because they always couple. They always couple number of NCERT logics in a question. If you say they give you independent question from a chapter, then no. Probably yes, you may have a good question from ionic equilibrium. I have a question from ionic equilibrium. But yes, if only one chapter from one chapter they are asking question, then the framing of the question will be good. है ना? चलो. Okay. Now, sir, this is my compound reacting with NaBH4. Sir, NaBH4 is a reducing agent. Reducing agent reduces whom? They reduce aldehyde, they reduce ketone, and they reduce acid chloride. So those reducing, this reducing agent reduces aldehyde, ketone, and acid halide. Sir, this is ether. This is aldehyde because this is CHO, and that's it. I do not have any other functional group which can be reduced by NaBH4. So this aldehyde will be reduced. So this A is quite easy to be made. 6-membered ring. Then I have a CH3. Then I have OMe, which is an ether. Then I have this oxygen. This oxygen is having carbon, which is CH2. So at this side it is having CH2 with OH, and on that side that aldehyde will also be getting reduced and forming corresponding alcohol. So this is my A. I'm talking for reaction A first, है ना? Ozonolysis, obviously the bonds are as it is. Now ozonolysis. Sir, ozonolysis followed by hydration. So that means this is oxidative ozonolysis. That means here I am doing oxidative ozonolysis. So for ozonolysis, what we do, you see the double bond, you break the double bond. So this will be broken, this will be broken, and this will be broken. So first we will break the double bond and introduce double bonded O. So let us introduce those double bonds O. Sir, where? Let us form these groups first, because this carbon and this carbon, so I'm making the product upside, or let me make it on a different page, है ना? So one carbon and second carbon, so one carbon and second carbon. Sir, methyl and a double bond O this side and a double bond O this side. So methyl and a double bond O this side and a double bond O this side. I hope this first fragment is formed. So this first fragment is having the carbon that I'm having over here. This carbon is having 4 bonds, but this carbon is having 3 bonds. And because this is oxidative ozonolysis, so this will become OH. This will be the oxidative ozonized products of the first part, which is this. What else, sir? Sir, one carbon, second carbon. This will also form second part. So 2 carbon. So first carbon, second carbon, it will get double bond O from here and one double bond O from this side. One double bond O from this side. It is further connected with what? It is further connected with OMe. So this is OMe. Is it having one CH? Yes, sir. So that H will become OH because it is oxidative ozonolysis. This is nothing. So this is my first fragment. This is my second fragment. So this will also form the third fragment. So two carbons. Let me make those two carbons. So it will get double bond O from here. This guy will get double bond O from upside. What else it is connected to? So this is connected with O. This one is further connected with O, which is connected to CH2OH. Which is connected to CH2OH. I hope everybody is clear with me. I hope everybody is clear with me. A good question, a good question. Yes, we are practicing for advanced. No extra detailing, NCERT facts, but NCERT coupled with your common senses. So the three parts I have, sir. This is for option A. Now, sir, after that, because you have water, that means, sir, hydrolysis is definitely bound to happen. So hydrolysis of corresponding ester or whatever carboxylic acid derivatives we have, they will also form the corresponding acid. So finally, we have to think of their oxidized, their hydrolyzed products. So whether this can undergo hydrolysis, sir, this is ketone, no. This is acid, no. So this is a ketone, this is an acid, no, sir, no further hydrolysis we can see. Hydrolysis. So this is alcohol, na? So one of the product is this alcohol is the question option is telling us. So let us explore. Sir, no hydrolysis can take place over here. What about this guy? Sir, this is an ester. This is an ester. C double bond O and O. So here hydrolysis will definitely happen. Here hydrolysis will definitely happen. This bond will be broken. This bond will be broken. And this will get H plus, this will get OH minus. So this will be my corresponding carboxylic acid. And this will be my alcohol, which is methanol. So first product is this, second product is this, third product is this. I guess these are the same products, but still. Now what about this? So this is also oxygen carrying 2 O hydroxy group. So this will undergo definitely hydrolysis. Why? Because with this you can obviously see I have this will also get OH. This is a ketone, that means this is an ester. So this ester will be broken in this fashion. This will get H plus and they will get OH. So what I have over here, so this is formaldehyde, this is formaldehyde. I guess I just left one carbon or what? I just left one carbon or what? Yes, here I left one carbon beta. This is O connected with carbon. So this is O connected with carbon and having CH2 group. So I just have to redraw this structure because here you can obviously see this is O. This guy is an O. This benzene is an O connected with a carbon. This benzene, this carbon was having O connected with a carbon. O connected with a carbon. Again, I have not made that picture beautifully. So here you have to be a good designer, beta. Connected with a carbon, which is further connected with two carbons. So CH2OH and CH2OH. This is the picture error we have done. This is the picture error we have done, beta. Here, this was O which was connected with carbon. So here, there is a picture error we have done. So let me correct this over here also. Carbon connected with two carbons. So this also CH2, this also CH2. I have made that over here. And because this is an ester, so this ester will be broken. How? It will get OH, it will get H. So here I have what? So 1 carbon, 2 carbon, 3 carbon. That means 1 carbon, 2 carbon, 3 carbon. This carbon is also having OH. That carbon is also having OH. And the third carbon will just be introduced with an OH. That means this is nothing but glycerol. A beautiful question, beta. And the question is telling you that whatever products I'm having, one of the product is glycerol. This is definitely correct. So this is definitely correct, and again the question is which does not represent correct. So this represents correct thing, so that's why this is not an option for us. A good question, and we have just explored one option, beta. We are still, the product is incorrect. Nahi beta, this is one of the product. What we missed, because we have gone in the next slide, so we have incorrectly drawn the product produced, because NaBH4 will definitely reduce this aldehyde and will produce the corresponding alcohol. So this product I have not made properly, but this product I have made properly in the next slide. So I hope everybody is clear. So let me remove this from here, because now you definitely know how we have proceeded. And ultimately what has happened after first step is this NaBH4 will bring one H here and one H here. This H will be added as H minus, this H will be added as H plus. So this NaBH4 will reduce this aldehyde to alcohol, that we know, and remaining we have drawn in the next page. Now what about option 2, sir? Let us explore, sir. This is H plus, so protonation of this alkene will take place. So this is CH3 C phenyl CH3 and a positive charge. Sir, this is an electrophile. And I have one more alkene, sir. What is that alkene, sir? This is a benzene ring. This is C having CH3, double bond CH2, because I have two of these molecules. So this is electrophile, this is another double bonded carbon, and this double bonded, sir, pi bond of benzene is resonance stabilized, so who will be attacking this pi cloud? How? Sir, electrophilic substitution, where this pi bond will be added to this carbon. This pi bond will be added to this carbon. I hope everybody can see that. And once it is formed, where you will be finding that carbocation? Here, because that will be resonance stabilized. So let us make this structure. Let us make this structure as well, beta. So ultimately, sir, what you have is, you have a 3 carbon chain phenyl at second. I have a 3 carbon chain phenyl at second and a positivity, and this is supposed to attack a benzene ring containing the C, having double bonded C, and this guy is also having a methyl group. So this is the product that I'm going to create, creating positivity at this carbon. So one benzene ring connected with a C. This C will be getting a positive charge. Why? Because bond will be made through this carbon. So this CH3 I am drawing separately, and this carbon, which will be here, it will be CH2, will be getting this carbon. So this CH2 will be getting attached to this carbon. Now what is this carbon? This carbon is having 2 methyl group and a phenyl group. This carbon is having 2 methyl group and a phenyl group. This carbon is having 2 methyl group and a phenyl group. I hope everybody is clear with me. I hope everybody is clear with me. Now, so that means this has formed a bond with this guy. Now I have a carbocation over here. I still have got a carbocation over here. I still have got a benzene ring over here. This benzene ring will do what? Sir, cyclization, because this is an electrophile and this is a benzene ring which can again retain its aromaticity by electrophilic substitutions. So this electrophilic substitution will take place over here, and I will be having 2 benzene ring. And how many member ring I'm having over here? Sir, 1, 2, 3. This will be the 4th carbon. This will be the 5th carbon. So 1, 2, 3, 4, 5, with the next carbon having 2 methyl group, and this benzene is having attached to this carbon, it is having just 1 methyl group. Now let us explore the option, that the product that we have formed in the question. Sir, this is 1 benzene ring. Okay, sir. 1 carbon is having 2 methyl group, and the next carbon which is having that 5 member ring is having methyl also, phenyl also. Let us explore in the option whether we have phenyl and methyl. Yes, sir. Sir, this is my methyl and this is my phenyl. I hope everybody is clear. Yes, beautification of the question is really important here. So yes, you can again redraw the question because I'm having them on different slides. So once you are making them in your copy, it will be much clearer to you. I'll be giving you this notes after the session is done. Just go to PWJ English WhatsApp channel and you'll be definitely exploring these questions. So, but yes, these questions will help you gain confidence as well. I hope everybody is clear with me. Chalo. So that means, sir, this is also a correct product, so not an option. Coming to this one, now let us draw this product properly. This is my 6-membered ring, a double bonded carbon and a 4-membered ring. So let me draw this for you initially only. Let us draw this properly. Beta, please don't give any time constraint. We'll be just taking 15 more minutes because I am now enjoying myself. So you should also enjoy yourself. So talking about option C now. So this is a 6-membered ring having double bonded carbon over here and a 4-membered ring. Let us check. Yes, sir. This is a 4-membered ring attached with. Now it is treated with concentrated sulfuric acid and this guy is formed. Let us see how this pyro compound can be formed. Sir, I am having this. Okay. What else? Sir, this is treated with concentrated H+. So first of all, what is going to happen? Sir, protonation will take place. So let me make protonation of this. Once protonation is taking place, I'll be getting OH. And obviously this will be extracting electron and a carbocation. And a carbocation will be introduced here. Okay, sir. Sir, now we can see this is 4-membered ring, so ring expansion will take place. So ring expansion will take place. Hello? The product is incorrect because reaction and concentrated H2SO4 should trigger a ring expansion. Beta, I'm doing a ring expansion, silver boy. So I'm doing that ring expansion. So that ring expansion will take place. Okay, sir. That means this bond will come over here and a positivity will be coming over here. Let us do that ring expansion. So this is OH. What else, sir? Now this will become a 5-membered ring. So 1, 2. So 1, 2. Let me make that ring with different color. 1, 2. Then this will become the 3rd carbon, then 4th carbon, then 5th carbon, and it is attached over here. I hope everybody can see this. But sir, with this guy will get a positive charge. So this bond has broken. Because this bond has broken, so it has formed a bond at this side. Not this one. This bond has broken. Not this one. This bond is broken. Which one? This one. So this is 1, 2 and 3rd carbon. This is 1, 2 and 3rd carbon. That 3rd carbon has broken a bond with this carbon and made a bond with this one. So I hope everybody is clear with the picture. Now, I hope everybody is clear with the picture. Now this is your positivity. Okay, sir. What else? Sir, that means I have a 6-membered ring and have a 5-membered ring. But I have a positivity over here. If I get a positivity at this carbon, which one here? So this will be just like pinacol, pinacolone. Remember? Because once this carbon will have positivity, this oxygen will snatch electron from hydrogen and will bring a double bond. But in order to bring positivity at this carbon, what do I need? I need ring contraction, because 6-membered is free from bare strain, but 5-membered is also not highly strained. And alcohol, when subjected to concentrated acid, induces formation of a ketone. Remember pinacol, pinacolone rearrangement. So I'm giving you NCERT. Yes, in NCERT it is not there, but pinacol, pinacolone rearrangement is a very beautiful organic fact. So that means, sir, if you need a positive charge over here, then what can you do? I can break this bond and bring that sigma cloud over here. So it will make 5 carbon chain. That will also be a 5 carbon chain, but this guy will attain a positivity. So ultimately I'll be having how many? I'll be having 2 5-membered rings. 1 5-membered ring, and this will also form a 5-membered ring. Let me make it for you. So this is 1 5-membered ring. Let me make this ring separately. This is 1, 2, 3, 4, 5. So this will also be forming a 5-membered ring. 1, 2, 3, 4, 5. Sir, how it has been formed? This bond is broken. So positivity is gone, but positivity will be coming over here. It is definitely having one OH also. Now the hydrogen will say, now the oxygen will say, hey hydrogen, give me my electron. And H plus is lost, which we have borrowed from the catalyst. And what you have formed, sir? 5-membered ring. Another 5-membered ring. And a double bonded O over here. Now, if you just see this, they are two spiro compounds. So you can obviously make it beautifully how they are spiro compounds. So one 5-membered ring with this carbon it is attached. So let's say this is that carbon. So this is another 5-membered ring, and to the next carbon I'm having a double bond. Let us explore the option. Very beautiful, beta. So because this is correct, because this is correct, I am intentionally making you exhaust. Am I using any factual science? We are just doing permutation and combination with common sense. That whether bond can move, whether electron can be satisfied. And yes, I'm not saying these questions you will be dealing very easily in your paper. No, you should not attempt them. But actually practice them. Not because they are difficult. Yes, because they are time consuming, and you can attempt these questions once you have confidence in your paper. After doing that mains easy and moderate level of questions, then only you should attempt such questions. है ना? Guys, chalo. Last one. Sir, this is obviously, because this is not an answer, so obviously this will be my answer, but at least let us explore. Let me do it over here only, because writing the question is actually a problem. But you can write it, because you will be seeing that computer screen, and just draw your classwork, whatever you are doing in your rough sheets na beta, make it very, very clearly. The more clear you write, the more clear you attempt a question by writing it properly. Once you are going back to the question, at least you will not have to read or redo the question. Till whatever point you have reached, just leave the question at that point of time, so that even if you have got time to come back to the question, you will know where to proceed from. You do not have to start from zero. So that's why, because I have a limited space, and you guys will have a pen and copy, so you can keep on going in your pages. But please do, please do. Huh? Offline sirs can't. Chalo, Silver Boy, thank you, beta. Silver Boy, guys, like this video. This chemistry sir, beta, my name is Gaurav Singh Arora, or you can say GSA. So this chemistry sir deserves 1K likes. He solved every doubt of mine, even my offline sirs can't. Beta, if you are appreciating someone, it's good. Do appreciating someone requires, defaming others? They must also have been doing for your best, beta. Teachers always work for your best. Whatever they try to give you, they ultimately are giving you. So yes, you may find whatever I'm teaching interesting, but do not say bad things about anybody else. You are learning na, that is all teachers' intention, beta. Hai na? Chalo. Moving to the last question, which we already know is the answer, but still, sir, we are learning. So let us learn. Sir, H2SO4, H plus, sir, okay. Now what you say, sir, we already know. This is endothermic system. That is exothermic system, outside. So this alkene will not participate, that will participate. Okay, sir. Then this CH2 will be getting this H, and a positivity will be coming. Right? Why? Major isomeric product. This, acha nahi beta, no, because this is not conjugated alkene. What about hyperconjugation of this carbon? Let us check. If I have positivity at this carbon, I will be having 3 and 2 hyperconjugating hydrogens. What about if I have positivity here? So I'll have hyperconjugation 2, 4 and 6. No beta, this is more stable. So actually here here, because that is not a conjugated system. Mind you, this is not a conjugated system. So H plus will be getting attached to this carbon and positivity will be coming over here. Point number one. Now, once I have positivity over here, now definitely I can have what? Now, because this is the product that we are supposed to form. So now definitely what we can have is, I can have, this is, sir, rearrangement. Because this carbon will be hyperconjugation stable, not resonance. But if hydrogen hydride shifting will take place, the carbocation will be formed over here. That will be resonance stable, allylic carbocation. And that allylic carbocation will do what? Sir, further it will also undergo dehydration. And dehydration will produce an alkene over here. Why alkene over here? Because pi sigma pi will be a conjugated alkene. So actually I'm making this product just by iterating things orally. I hope you can understand and get that what I have said. So this bond is gone. I have got a double bond here, because this will result in a conjugated alkene. And what does SIDZEF tell you? That conjugated alkene, more stable product is formed. So this shall be the most stable product, but it is giving you obviously something else. So this is obviously incorrect. This product is obviously incorrect. And hence this is my actual product, and hence this is my answer, because this does not represent correct option. Perfect. Perfect everybody. Moving to, acha, I still have got questions beta. Chalo, moving to the last, these questions I'll be giving you as homework. So attempt this one, a good question from organic chemistry, linking you with facts of isomerism. Again a question. So these two questions I'm giving you homework. Let us explore this question, the last one. A question from Silver Boy. Everybody, last question. You can take this PDF from where? Just go to PW JEE English WhatsApp channel, the link to which will be given in the bio. Post my lecture, I'll be sharing this PPT, and you can obviously attempt those questions. Okay, chalo. I get 3 questions wrong. Very good. You just got 3 questions wrong, beta. Sudha. So please share. I will, beta, definitely. The moment the last question, just finish off with this question, and you can obviously attempt these questions back at home. Chalo. So let us read the question, beta. The question says, a solution contain mixture of silver cation 1 molar, Ag2 plus 2 cation 1 molar, which is to be separated by selective precipitation by adding iodide ion. Okay, sir, that means that their KSP value, okay, sir, KSP value is given of AgI and of Ag2I2, mercurous iodide, definitely they are sparingly soluble. 1 molar of cations I'm having, and I'm adding iodide ion. Obviously, who will be precipitated first? Who will be having lesser amount of I minus ion required for the precipitation. So let us first check that who will precipitate first. So what competition I have? I have Hg2I2. This solid will be dissociating as Hg2 plus 2. Very few ions. Mercurous, because mercurous exists as a dimer, and twice of I minus. Right? So the value of KSP given for this one is 4.9, as in 49 into value of KSP is 49 into 10 raised to the power minus 26, na? Because 25. So 49 into 26. Okay, sir. This is equal to what? This is equal to concentration of ions. So I minus squared into Ag plus 2. The metal we are adding as 1 molar. So this is I minus concentration squared into, for metal it will be 1 molar power 1, because their concentration are 1 molar each. Okay, sir. So how much iodide ion can be accommodated till precipitation? So at equilibrium, how many sir, under root? So this is 7 into 10 raised to the minus 13. Okay. Let us compare for, this is for mercurous iodide. Let us do it for the other salt, which is AgI. So for AgI, sir, the solid will be precipitating as Ag plus and I minus. value of KSP for this guy is 7 into 10 is power minus 7. 7 into 10 raised to the power minus 16 will be equal to concentration of I minus, that is allowed to be dissociated as aqueous ion. Very limited it will be, but still let us check how much it is. And Ag plus is definitely 1. Okay, so now we have to compare these two data. This one and this one. Which is less beta? Obviously, sir, minus 16 is, this is here, denominator is minus, that is minus 16, 13, that is more. So this is less. So who will be precipitated? Because this is less, that means AgI will be precipitated first. Now let us explore the question. The question says if X is the percentage of one metal ion precipitated, okay, that has already been precipitated. Who will be getting precipitated? AgI. So AgI will be getting more and more precipitated. But you have to compare its precipitation till where? Till second metal ion starts precipitating. So when the second will start precipitating, when the concentration of I minus will be increased and reaching till this value. So at this concentration of iodide ion, the precipitation of Ag2I2 will start. But once that will start, concentration of iodide ion will reach this value. At that point, what will be the concentration? What will be the aqueous ion present of silver? Because initially, how many silver ions I had? Initially, I had 1 molar Ag plus ion. Initially, in the solution. Once concentration has reached to this value, at that point of time, how many Ag plus ion I have in the solution? Let us find it. How will we find it? Sir, value of K never changes. So value of K for AgI will always remain 7 into 10 to the power minus 16. So value of K for AgI, value of K will not change, which is always 7 into 10 to the power minus 16. So 7 into 10 to the power minus 16 will be equal to Ag plus, which is still there in aqueous condition. I have taken 1 molar. Precipitation of that 1 molar Ag plus has started, but still some will be there. How much will be there in solution? Sir, you have to just take concentration of I minus as what? As this much, because at this concentration, mercurous will start to precipitate. So once it will start to precipitate, I have to calculate Ag plus at that point. So KSP I minus concentration is 7 into 10 to the power minus 13 at that point. So this is, so Ag plus ion present in aqueous solution is what? This will be 7 into 10 to the power minus 16 upon 7 into 10 to the power minus 13. So for I minus, it will be 7 into 10 to the power minus 13. Calculation is also easy. It is 10 to the power minus 3. That means 0.001 moles per liter. So sir, what is X? What is X? X is the percentage of one metal ion precipitated. So what I have taken initially 1 molar, what I still have in solution, that much. So what is the difference that has been precipitated? The difference. So X is number of moles of Ag plus that I have initially minus number of moles of Ag plus that I still have in solution at my final state, upon what was there initially, upon what was there initially. This is also initially. So what is the number of moles I had initially? 1 mole. 1 molar. So 1 mole in 1 liter. Minus 0.001 upon how much I had initially? 1 only. So this will be the fraction. So percentage will be into 100. So let us do This is obviously 0.999. So this after 100 it is 99.9%. So your answer will be 99.9. Aha, silver boy. Silver boy. Perfect. Chalo, good beta, good. Everybody good, everybody great. So this is it from my side. Yes, I am having few 2-3 questions more for you, which will be obviously they are given, so they'll be your practice. Beta, please make sure that you are revising things really religiously, really properly. I wish you all the very best. Thank you very much. And keep studying. All the very best for your examinations. So, bye bye. Take care. Download these notes and practice them from PWJ English WhatsApp channel. So, bye bye. This is it from